Ever wondered if you could hop into a time machine and meet your younger self, or see what the future holds for you? Time travel, an idea that has been a mainstay in science fiction, has long fascinated us, sparking our imaginations and fueling countless movies, books, and TV shows. From H.G. Wells' Time Machine to the DeLorean car and Back to the Future, the concept of journeying through time is deeply embedded in our popular culture. We've all had moments where we wished we could turn back the hands of time or fast forward to see what lies ahead. Time travel tantalizes us with the prospect of correcting past mistakes, reliving cherished memories, or peering into the unknown future. Yet beyond the realm of fiction, the question remains: does time travel have a basis in reality? Could it be more than just a captivating idea? But is time travel just a figment of our imagination, or does it hold some scientific truth? Before we delve into the possibility of time travel, it's crucial to understand what it really means. In its simplest form, time travel is the concept of movement between distinct points in time, analogous to how we can move between different points in space. But rather than stepping into a shimmering portal or boarding a DeLorean, we're all already time travelers of a sort. In fact, we're doing it right now. Yes, you heard that right. We're all moving forward in time, second by second, minute by minute. Each tick of the clock pushes us into the future, making us older, wiser, and perhaps a little more wrinkled. But time travel isn't just about growing older, it's also about the fascinating concept of time dilation. This is a real, observed phenomenon that comes straight out of Albert Einstein's theory of relativity. You see, time doesn't flow at the same rate for everyone and everything. It can slow down or speed up depending on how fast you're moving or how much gravity you're experiencing. Imagine this. If we put a precise clock on a spaceship and sent it zooming around the universe at near light speeds, when it returned, it would read a different time than the clocks here on Earth. Astronauts returning from missions often find they've aged slightly less than their counterparts who stayed on Earth. This is time dilation in action, a form of time travel to the future. So, time travel is not just the stuff of science fiction. It's a reality, albeit in ways we don't often consider. It's not about jumping into a time machine and popping out in the Jurassic period or the distant future. It's about the constant, relentless march of time carrying us forward, and the subtle ways in which time can be stretched and squeezed by the laws of physics. So we see that time travel isn't just about flashy machines and wormholes. It's something we experience in our daily lives. Now that we have a better understanding of time travel, let's examine its theoretical possibility. One of the most intriguing aspects of time travel is its basis in real scientific theory. Yes, it's not solely the stuff of science fiction. One of the most prominent theories supporting the concept of time travel is Albert Einstein's theory of relativity. Einstein's theory of relativity, developed in the early 20th century, fundamentally altered our understanding of space and time. It proposed that space and time are intertwined into a single continuum known as space-time. According to this theory, massive objects cause a distortion in space-time, which is perceived as gravity. This is somewhat analogous to a bowling ball sitting on a stretched-out sheet, causing the sheet to dip. Now, how does this relate to time travel, you may ask? Well, Einstein's theory also implies that if space-time can be warped by gravity, it could also be warped by speed. If one were to travel at an incredible speed, close to the speed of light, time would appear to slow down for the traveler, relative to someone stationary. This is known as time dilation. Therefore, theoretically, a journey into the future is possible. Another fascinating theory is the concept of wormholes. A wormhole is a theoretical passage through space-time that could create shortcuts for long journeys across the universe. If these wormholes exist, and if we could travel through them, they could potentially allow us to travel both forward and backward in time. However, it's crucial to note that these are all just theories. While they provide a fascinating framework for the possibility of time travel, they are not yet backed by empirical evidence. We are still a long way from hopping into a time machine and journeying into the past or the future. While these theories may seem to support time travel, it's important to remember they are just that, theories. While theories might suggest the possibility of time travel, putting it into practice is a whole other ballgame. Time travel is not as simple as hopping into a DeLorean and hitting 88 miles per hour like in the movies. It comes with its fair share of challenges and paradoxes that make it a complex and intriguing subject. Take for example the infamous grandfather paradox, a popular conundrum in time travel lore. Picture this scenario. If you were to travel back in time and, in a strange twist of fate, accidentally caused the demise of your own grandfather before your parent was born, how could you exist in the first place to travel back in time and set this chain of events in motion? This paradox raises questions about the very nature of time and how changing past events could create a ripple effect on the timeline, potentially altering or erasing the future we know. Another challenge associated with time travel is the immense energy requirement for creating a wormhole, a theoretical passage through space-time that could potentially allow for travel to different points in time. According to some scientific theories, creating a stable wormhole would require a form of matter with negative energy density, something that is not known to exist in our universe. And even if we could create a wormhole, keeping it open long enough for someone or something to travel through is another hurdle altogether. Moreover, the effects of time dilation could pose a significant challenge. According to Einstein's theory of relativity, the perception of time can change depending on the speed at which one is moving. This could mean that a time traveler might age differently compared to those not undertaking the journey, which could introduce a host of other complications. These challenges make the actual implementation of time travel a daunting task. But even with these obstacles, the allure of time travel remains, firing up our imaginations and fueling our desire to unlock the mysteries of the universe. Scene script. Despite these challenges, the fascination with time travel continues. So, what does the future hold for time travel? Now let's dive into the future, a time that's yet to be written, where time travel might just become a reality. The field is ripe with ongoing research and theories, and some of the brightest minds are working to unravel the mysteries of time. A key player in this quest is quantum physics. This branch of science has given us a fresh perspective on how we understand time. It's suggested that time isn't linear as we've always believed. Instead, it could be just another dimension, like length, breadth, and height. And if that's true, then theoretically, we could move around in time, just as we do in space. Then there's the concept of wormholes, which are essentially shortcuts through space-time. These cosmic tunnels could potentially allow us to hop between different moments in time. However, creating a stable wormhole is a colossal task, and we're still far from achieving it. Parallel universes, too, are a fascinating aspect of modern theories. If they exist, each universe could be a replica of our own, with time flowing at different rates. So, in theory, moving to a parallel universe could be synonymous with time travel. But here's the thing, these are all theories, and theories need proof. As of today, we don't have any empirical evidence to substantiate these ideas. The technology required to test these theories is currently beyond our reach. We're talking about energies and scales that are unimaginable with our current understanding and capabilities. This doesn't mean we are giving up. No, far from it. Science is a relentless pursuit of knowledge, and our curiosity is the fuel that drives us forward. We continue to explore, to question, and to dream. While time travel remains a fascinating concept, its actual realization might still be a thing of the distant future. But who knows? One day we might just be able to hop into a time machine and journey to the past or the future. Only time will tell. So, is time travel possible? The answer isn't as straightforward as we'd like. We've journeyed through the concept of time travel, understanding it from the perspective of science and theory. We've seen that, in theory, time travel is a possibility. Einstein's theory of relativity opened up a world of possibilities, suggesting that time isn't a constant, but a variable that can be manipulated. Yet the practical challenges of time travel are monumental. The energy required, the potential paradoxes, and the physical toll on a time traveler are all significant hurdles to overcome. It's like standing at the base of an enormous mountain, looking up at the summit. The climb seems impossible, but the view from the top could be extraordinary. For now, time travel remains a captivating theory, a tantalizing possibility that continues to intrigue scientists and laymen alike. We may not have all the answers, but the quest for knowledge continues, ever pushing the boundaries of what we understand.